Hi guys, let's do assigned cookies. So they say assume you're an awesome parent and want to give your children some cookies, but you should give each child at most one cookie. Each child I has a greed factor, G of I, which is the minimum size of a cookie that the child will be content with, and each cookie J has a size S of J. If S of J is greater than or equal to G of I, then we can assign the cookie J to the child I, and the child I will be content. And our goal is to maximize the number of the content children and output the maximum number. So in example 1, we're given input G equals 1, 2, 3, and S equals 1, 1, and we would output 1 because we have 3 children, and each of these children's greed factors are 1, 2, and 3, and we have 2 cookies of size 1 each. So we can make at most one child happy, because if we give this child a cookie of size 1, then they will be content, but these other 2 children who have a greed factor of 2 and 3 will not be content because the cookie of size 1 will not satisfy them. So we can only satisfy one child. In example 2, we're given G equals this array and S equals this array, and we would output 2 because we have 2 children and 3 cookies, and the greed factors of 2 children are 1 and 2, and so we can satisfy both of the children with any of these cookies. So we would output 2. So for this one, we just need to make sure our input arrays are sorted first of all, and then once they're sorted, then we can just have a pointer for each array that is traversing backwards, like from the end of the array to the front. And every time that we have S of J is greater than or equal to G of I, then we will increment a count that is tracking how many content children we have. And that should be pretty much it. So let's go ahead and do that. So let's first of all sort our 2 arrays. So we'll say arrays.sort G and arrays.sort S. And then we'll have a counter to track the number of content children. So we'll say int content equals 0. And then, so I'm going to do a loop that is looping through G. So I'm going to have just another variable that's tracking the pointer for S. So we'll just call this one J, and we'll start it at s.length minus 1. So we'll start it like at the end here. Because the reason why I'm making the loop through G instead of S is because we're done iterating when we're done with when we've visited all of the children, because we don't really care if we visited all the cookies. Like in example 2, we have extra cookies, that's totally fine, but we need to make sure that we iterate through every child, because in this case, like if we are done iterating through the cookies but we're not done iterating through the children, then, well, I guess actually either way should work. Yeah, I think either way should work, but whatever, I'm still gonna do it this way. So we'll make this s.length minus 1, and then we'll make our loop looping through G. So we'll say for I equals G.length minus 1, I is greater than or equal to 0, I minus minus, and then we will check. So first of all, J needs to be greater than or equal to 0, otherwise we can't do anything, because that means we're out of cookies. So J needs to be greater than or equal to 0, and we're not going to do anything unless S of J is greater than or equal to G of I. So if S at J is greater than or equal to G at I, that means that the cookie will satisfy the child that we're currently at. So if that's the case, then we can increment our number of content children, because this cookie will satisfy that child. And then we can decrement J, so we'll say J minus minus, because J is tracking what cookie we are currently at. So if we used the cookie, then we're going to need to move on to the next cookie, because we can't use that one anymore. And then I will automatically decrement every single iteration, so we don't need to do anything about I. So that should be pretty much it, and we'll just check this for every single I and J, I being the child and J being the cookie, until we are out of children, or cookies, depending on how you do it, but children in this case, and then we'll just go ahead and return the number of content children. And that should be it. So let's check. Okay, now our time complexity. So we just have one loop here, which is looping through the number of children. So that's O of n, where n is the number of children. This one, we also have sorting of the two arrays. Oh, by the way, this is O of n, if I didn't already say that. And then this, so we're sorting the two arrays. So that's going to be O of n log n, where, well, n log n and m log m. Let me type that out so it's not confusing. O of n log n is number of children. We'll call this one O of m log m. M is number of cookies. Yeah, and then in this case, because we're looping through, well, actually, okay, let me actually call this O of n plus m, because we are looping through each of the children and we're looping through each of the cookies. So like it's still constant, but it depends on the length of both of the arrays. So n equals number of children and m equals number of cookies. Yeah, okay, but in this case, it doesn't really matter because it gets taken over by this. So this is technically like O of, well, these two combined, I guess. So n plus m log n okay, you know what? I'm not gonna n log n plus m log m. You know what I mean. Why was this like the most complicated thing ever? I don't know, but okay. Hopefully that made sense. Space complexity is just O of 1 because we don't have any data structures here. So that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!